In section 5.2, problem number 43, we're asked to verify that these two values are the same. That is sine of 45 degrees minus 30 degrees, which is a way to use the sum identity to find the value of sine of 15 degrees. And the one on the right, which is sine of 135 degrees minus 120 degrees, which is another way to use that sum identity to find the sine of 15 degrees. So this exercise is to show that either method you use, you should get the same results for sine of 15 degrees. So using the sum identity for this one first, that is that the sine of alpha plus beta, or 45 degrees minus 30 degrees, equals the sine of 45 degrees times the cosine of 30 degrees minus the cosine of 45 degrees times the sine of 45 degrees. So that equals sine of 45 degrees is radical 2 over 2, and the cosine of 30 degrees is radical 3 over 2, minus cosine of 45 degrees is radical 2 over 2, and sine of 45 degrees is 1 over, I think I messed up here. This one should be 30 degrees. That's beta, is 1 over 2. Okay, there we go. And let's see, when I multiply these together, I get a radical 6 over 4 minus radical 2 over 4, or just radical 6 minus radical 2 over 4. So that is our value for the left side of this question. So let's see if we get those same results when we use the sum identity with 135, alpha equal to 135 degrees and beta equals 120. So let's try that same formula, but this time do 135 minus 120, which gives me sine of 135 degrees times cosine of 120 degrees minus cosine of 135 degrees times sine of 120 degrees. And then sine of 135 degrees, that's radical 2 over 2. Cosine, that's positive, yeah. And cosine will be negative because that's the x value on the left side of the quadrant 2. So that'll be negative 1/2. Okay, right. And then cosine of 135 degrees will be negative again because that's an x value. So that's negative radical 2 over 2. And sine of 120 gives me radical 3 over 2. Now when I multiply these together, I get a negative radical 2 over 2 minus a negative. So I'll just go ahead and make that a plus. Radical 2 times radical 3 gives me radical 6 over 2. So that gives me negative radical 2 plus radical 6 all over, these should be 4. Doing that same mistake again. So when I multiply those fractions, I get 2 times 2 gives me 4 over 4. And addition and subtraction are cumulative, which means I can switch the order of these, which gives me radical 6 minus radical 2 over 4, which is equal to this So either way, purple way or green way, we still get the same answer to find that non-standard angle.